Hey everyone, it's Chat here. Today we're tackling the LeetCode problem 3 longest substring without repeating characters. I'll walk you through how I'd solve this in a coding interview, from understanding the problem statement and devising a plan to coding, testing for errors, and evaluating time and space complexity. I'll be solving this in Python and I'll think out loud and ask clarifying questions just like in a real interview scenario. Let's get started. First of all, let's read the problem statement and try to understand it. So, for this problem, longest substring without repeating characters, we have the following problem statement here. So we are given a string S, and we want to find the length of the longest substring without repeating characters. Right. So what is a substring? First of all, is it a contiguous? Let me take this first example here. So when we say a substring, is it A, B, C together, then B, C, A together, like this? Or can it be B, then A, then B? Like, could we have, spaces between the characters forming the string? My understanding of a substring is that we do not have any spaces, so it should be contiguous. So we should take an I and a J, with J strictly superior, superior or equal to I, and S of ij gives us the substring. Let's confirm it is a contiguous, and it should be non-empty sequence of characters with a within a string. Yeah. So I will ask then questions about the length of S. Can it be empty? If it is empty, will the longest substring, the length of the longest substring should be equal to 0, because it's not possible to have a substring there. So I would, immediately check if length of string is 0, then we can return immediately 0. And if it is equal to 1, then we can immediately return 1 too, because what matters here is the fact that we do not have any repeating characters. So now let's try to work on the first example here. Let me try to find the length of the longest substring without repeating characters. So let's say I'm looking for A. I can, as I have only A here, one other thing that I would ask is, what are the type of characters that we might have in S? And we do have the answer in the constraints. In addition to the length of a string that could be equal to 0, we know that we only have English letters, digits, symbols, and spaces in there, so we can have lowercase and uppercase letters in there. Okay. Let's try to work on this one. So A is unique. So we can increment to B, right? And if B is also in there, we can, B is it's the first time we're looking into it, so we can increment it. Sorry, let me give my initial idea that I do have is to use a hash map, or should I say a set, to keep track of the characters we are currently tracking, to keep track of the characters we're currently looking into. So as we have A, I would say A is there, B is there, C is there, and when we find something that is already in the visiting set, what I could do there is remove A, right? Okay, I do have an algorithm, a solution here. What I can do is, okay, I'm increasing the length of substring ABC. I could increase it, but I cannot increase it further because we want to have non-repeating characters in the substring. So now I have to reduce the length of this one as long as we have A in there. So we can decrement it. So we end up with this. Then B is already in there. So I will decrement it. Then C is already in there. So I would do this. B is in there. So I should, as B is already in there, I have to decrement it. I have to remove A. B is still there. So I have to remove the B from here. And then I can move forward. But for this second B, I have to remove everything and end up with the singleton B by the end. And we will stop because we've touched the end of the string, right? Okay. And so to do this, what I plan to do is, okay, I'm planning to use a set actually to keep track of, sorry, oops, I think I clicked on something. So set. Then I also want to use I and j 2 pointers. So they give me the start. I can call them start and end. For clarity, start and end. The 2 pointers that gives me, for the substring. And I will have, for the current length, it is pretty simple because let's say I have this start equals 0 and end is equal to 2, right? Start is equal to 0 and end is equal to 2. Then the length of the substring is pretty simple. It is end minus start plus 1, which gives me 2 minus 0 is 2, plus 1 is 3, which gives me exactly 3 values in here. So this is the formula that I will use to get the length of a substring, right? And the way I will proceed is increment end when new character, when n plus 1 exists, and as n plus 1 is not in the set, right? And we would increment start when we meet a character when, while and add it to the set, right? And update the max length. So I will use max substring length to actually keep track of the maximum length of substring. Or maybe I can call this longest substring length. Let's call this way. And I will increment start when s n plus 1 is exists and sn plus 1 is in the set. And what we have to check there is pretty simple. We have to check that yeah, we just have to check. We just have to increment start when the next character exists and n plus 1 is still in the state. Right? And once we are done, we can return longest substring length. There we go. Let me just use these to represent the variables. Okay. I've now completed devising a plan. I now want to move on to coding and implement my solution in Python. Let me do it here. So first of all, I want to initialize left and right, where left, first of all, I want to remove, the edge cases where if length of s is strictly inferior or equal to 1, we know that we can simply return length of s, right? If it is 0, it's 0, and if it is 1, it's 1. Now that the edge cases are covered, I can initialize left and right. I can create my current chars. That would be a set. And then left is equal to 0 and right is equal to 0. And there's one other thing that I have to do. I have to increment start when exists, but before this, I can also check left is strictly inferior to right, right? Because we do not want to end up with left to the right of the right. So there we go. Left is equal to 0, right is equal to 0. And we start the loop. I also want to have the variable to store the result. Yeah, the result I can call substring len. Oh, maybe I should use long. Let me replace whenever I used. There we go. This will be the result, right? And while right is strictly inferior to length of s, so we should stop as soon as right is equal to n, in which case we've gone beyond the limits. Let me think about this. So we want to find the longest substring, and so left start at 0, right start at 0, and while, and right is the one that we use to actually add. So what I'm doing here is if s of right not in current chars, what I can do here is add s right to current chars, then now that I've added this one, we know that the see, we confirmed here that s right exists. If that's the case, and it is not part of not repeating character, we add it, and by adding it, we've got the longest. We can update longest substring length. That's going to be maximum between this one and the new length, that is right minus left plus 1. There we go. And yes, else. So if right is not a new character, what we do is while left is strictly inferior to right, if not, we are not going to increment There's one problem. I want to take this second example just to example 2. I want to see, because I'm seeing some problem with my current solution, my current idea. So let's say I have this one, left is equal to 0, right is equal to 0, and we know that b is not in there. So b is not in there, so we're adding it, and we know that the maximum length is equal to 1. Okay, I don't need to start with 0. I know that it's at least 1, right? And here, I can, as I check that I at least have one value in there, I can start with right is equal to 1, right? The set already has So I can start with the first two values, and the set can be actually equal to the first value of s. There we go. This changes a bit. Well, right is strictly inferior to length of s, so that's the case here. I am checking if s of I is not in current chars, which is the case, so we pass here. And while left is strictly inferior to right, what I do is end s of right s right in current chars, which means that this value is already b is already in there. That's the case. If that's the case, what do we do? Then we increment left. Before incrementing left, we have to drop it. So current chars drop remove s of left, and once that's done, we increment left. So we've removed this one, and we have left and right at the same position here. Now, if that's the case, actually, I did not have to do this. Okay, because if we end up in the situation where left is equal to right, because I can have the situation where left is equal to right, which means that the next value is the same as This is something that's curious because we know that s right. How is it possible to check the same value? Okay, we should not end this in this situation. That's the point. So if left is strictly inferior, not to right, because we know that we already have longest substring is equal to 1. So while left is strictly inferior to right, minus 1. So what I'm doing here is Okay, no. I don't have to do this. While left is strictly inferior to right, what I'm doing here is s right in current chars. I am moving the left right. So what happened here was that, okay, right is here, left is here. We know that s right is already in current chars, so we are moving left to the right. So we removed that one, and left and right end up being equal. But in all cases, we end up incrementing right because we've explored it. So the point here is that I want to reformulate this one. Let me get this one from here. So I want to, oops, sorry. If s right not in current chars, not repeating, is it a repeating character? If that's the case, I'll be actually moving left remove all characters until the repeating one. Okay, let me not write this down here, but here, remove all characters until the until the one that's going to be repeated. That is going to be repeated. So that's what we do here. While left is strictly inferior to right, we check if sRight is still in current chars. If that's the case, we remove current chars left and we increment it by +1. In all cases, once it's done, we know that now I can add sRight again. And update longest substring to be equal to maximum of this and this. And let me just, but this is, so I don't need this actually, because this is covered here. So it's pretty simple. My bad. Repeating character. I can remove this. And now that I do have this to actually move left, then I just add this one and update right. Now that the longest substring is done, let me now test it. Return this. I'll be using the example 3 to test this. Let me copy that. So what happens here? So we know that the length of S is 1, 2, 3, 4, 5, 6, 6. So it's not inferior to 1. So we're not just returning 0 or 1. Right. Then current chars is set to actually the first element P. Then left and right are 0 and 1. Right. We have P, then we have W. So we can increment it. So what happens? Right is still inferior to N. It hasn't reached the end of the end of S. So we can increment. We can check this one for right. So while left is strictly inferior to right, left is strictly inferior to right, and sRight in current chars, which is not the case. W is not in there, so we just do not look into this. We add PW. Once it's done, left, right is still, and we get 1 minus 0, plus 1. So 2 is the answer. Result is 1 here, and result is 2 here. Left and right, 0, and right becomes 2. Next step, W. W is in current chars. So what we do is we remove S left. So left is equal to 0. So P is being removed. So we end up with W, but W is still in there. So we're gonna once again remove W and left, right, with left being 0, 1, 2. Left ended up at 2, and right is actually being inserted here as W, and it's 3. Then K is not in there, so it's pretty simple. And result is actually here still 2 because the length of this one is 1. Yeah, there's also another way actually to measure the length, that is to count just the elements in the set. W and K, then let me just, E is also stored there, and W is not stored, so the result should be 3 with my 1. And when we end up to W, what happens is that left is strictly inverted to right, and it just removes the W from here, and there's no order in set, but let me just, to show it here, I've put together multiple steps here. And in the end, right gets incremented to length of, we go beyond the bounds, and so we just end this one. Let me run this now. So it passed all the tests, and let me now submit this one. Yeah, that's it. It works. And for the space and time complexity, space and time complexity, well, for the space complexity, it's pretty simple here. We are only using some variables. So what's the worst case scenario? So if we have only unique characters in here, well, we'll end up with a set that is as long as S. So it's O of n, with n being the length of S. The second one is the time. And for the time, we are iterating over S only once. Right is moving forward and left cannot move beyond right. So it's O of n too. This completes my walkthrough solving this problem in Python. That's it.